Okay, this is question 5 of the D1 2012 January paper. So I'm going to have a go at drawing these lines on the feasible region first of all. So I'm going to draw the line y equals 20. That's just y equals 20 is this line here. I'll do the shading all at the end. I'm just going to crack the lines in first. There's my line, y equals 20. Okay. X plus y is greater than or equal to 25. So that's that there. Oh, this is one of those horrible ones, isn't it? 25. Do you notice how 25 is on the x-axis? Let's think again. Let's get rid of that line. I'm going to get a pen out, and I know it's going to go from 25 on this axis to, let's be really clever here. If x is 20, I know that y is 5, yeah, because 20 plus 5 gives me 25. So I can now rule my line between them. So from there, down through there like that. Okay. 5x plus 2y equals 100. So when x is 0, y is 50. And when x is 0... Hang on, I've said that. When x is 0, y is 50. When y is 0, 5x equals 100, x is 20. So this line here... Shall I write something down, actually? So when x is 0, I know that 2y is 100, so y is 50. Sorry about this, I'm doing this with a mouse. I'm going to have to give up on this in a sec. Y is 50. So that's that point there. Just going to say it one more time. Now, when y is 0, you get 5x equals 100. Divide by 5, you get x is 20. So to draw this third line here, this one here, get your ruler, and it's between that 50 there and that 20 there. Okay, y is less than or equal to 4x. Well, when x is 0, y is 0, so it goes through the origin. Let's think of it, let's be smart here. When x is, I don't know, 10 seems like a nice number. Always go for the nicest number you can. 4 times 10 is 40. So when x is 10, y is 40, which is there, I hope. Looks right to me. Okay, take your ruler. And you only ever need 2 points to define a straight line. Bang your line between them. Okay, and finally, y equals 2x. Ah, it's more the same, isn't it? So when x is 0, y is 0, and when x is, I don't know, 10, y is 20 will do nicely, I think. So that point there, with a red pen there. So get your ruler, and there we go. So now, okay, happy with that. I think I'm about to get my 6 marks. I think I've got 4 or 5 of them. I need to indicate my feasible region and do the shading. So let's have a look at that. If I get my, let's use red to shade it out. So y is greater than or equal to 2x means I shade this side of the line. So I'm working back up to the top now. Y is less than or equal to 4x means I shade this side of the line. Let's scroll up a little bit. I'm losing sight of them. Okay, 5x plus 2y is less than or equal to 100. That, of course, was this line here, so I shade that side of the line there. X plus y is greater than or equal to 25. Greater than or equal to means I shade this side of the line here. And the top inequality, y is greater than or equal to 20, means I shade that side of that line there. Meaning, you must do this, you must label the feasible region. Okay, so that's taken care of part A. Let's have a think about B. Use your diagram to find the minimum value of P in the feasible region. Okay, so B part 1. The way I play this is I rearrange it, so 2y equals minus x plus P, which means y equals minus a half x plus P over 2. Now, you don't care at all about the P over 2, because P can take on a whole load of different values. What you're really interested in is this minus a half. So you know your objective line is going to have gradient minus a half. And that tells me for every 1 I go down, I go 2 across. That's how the objective line works. Now, that's going to be a bit puny, okay? I've got to make that bigger. I'm thinking for every 10 I go down, I go 20 across. That would be a nice big objective line. So if I mark there and I mark there, I can put in that objective line. So let's do that. Let's make that our next job. See if I can change the colour. Let's go. What should we make it? A nice. Oh, I can make it blue, in fact. So there's our first objective line. Now this is the method here is it's really quite bizarre actually. You get a ruler and you run it parallel to that line. You're not going to be able to see me do this very well, and it's the last place where you leave. Oh no, because we're minimising. It's the first place you enter the feasible region, and this happens if you move that blue line up. This is going to be a bit rubbish. I might have to undo this. I'm going to give it a go. So get hold of the blue line, move it up as if it's parallel to it. Now the first place you enter the feasible region is, you probably saw it as I went up. I'm going to get the highlighter pen to show you where it is. The first place you enter, because it's the minimum, is that vertex there. That vertex there has coordinates 5 and 20. Yeah, just read them straight off. 5 and 20. Okay, so we want to minimize P. So all this works with B part 1. So therefore, the answer to B part 1 is 5 plus 2 times. Sorry, I'm running out of space. Shall I? Let's go underneath. So for B part 1, it's going to be, so P equals, I'm looking up here. Oh, sorry, I didn't mean to rub it out. So it's going to be 5 plus 2 times 20, which is 45. Okay, B part 2. Okay, I want to minimize, okay, so it's P equals minus X plus Y. Rearrange that to get Y equals X plus P. So now, the gradient of this objective line is 1, which means for every 1 you go across, you go 1 up. Okay, let's draw an objective line on. It does that. So my objective line, this time I'll stick with the blue. My objective line here, let's give myself a point first to work with. So for every 10 I go across, I go 10 up, for example. So every 10 I go across, I go 10 up. So my objective line is going to go through there, like so. So this is my second objective line. Okay. Now same principle. I'm going to move that up, and it's the first place where I enter the feasible region. Okay. So again, it's going to be rubbish, but bang, it's there, isn't it? We can see it. Let me get my highlighter pen out. So this time, the vertex is there. This corresponds to, you can read it straight off the graph again. It corresponds to x being equal to, so here, let's come out here. X is 10, y is 20. Sorry, x equals 10, y equals 20, i.e. we're at the coordinate 10, 20. So, in terms of P, because P was equal to minus X plus Y, that's equal to minus 10 plus 20. Therefore, P is going to be 10. And that's the answer to B part 2.